So this topic is networks, and we've called it finding the right path. So what we're looking at are network diagrams and terminology, being able to solve them and find the shortest time to get to a destination. So there's a lot of terminology that we need to know and that's new for us. So we have our vertex or vertices, which is a point on a network, also known as a node. So that would be like these little points on the end here. We have an edge, so a line that joins our two vertices. We have a degree. A degree of a vertex is the number of edges that it's connected to. So you can see here from this node or this vertex, there are 3 edges or 3 lines that move from it. So therefore it has a degree of 3. And this one having a degree of 2, there's only 2 lines coming from it. A loop, so an edge that starts and stops at the same vertex. So this only counts as one edge, but a degree of 2 because it is coming and going from there twice, so to speak. We have a directed edge. So as arrows on the edge and travel can only occur in that direction. So we can only go from B to C this way. We couldn't come back this way. We have a weighted edge, so a number assigned to it might be the distance that you're traveling. So between Bathurst and Sydney, there's 200. It could be kilometres, it could be metres, depends on what the context is. We have a traverse. So if you can traverse a network, it means that you can visit all vertices by traveling along every edge exactly once. It's only possible if all its vertices are even. So that's a really important point there, if it's even, or if it has exactly 2 odd vertices and the rest are even. So you'd start at one vertex and finish at the other. So working your way around, you can get to every single point along every edge and you don't cross over anything twice. A walk is a route along the edges, so going from one point, walking around, whatever it might be. We have a trail. So a trail is a walk with no repeated edges, so it means you can't cross over the same edge more than once. So looking here, you can see that direction you're going through, but nothing is crossed over twice. We then have a path. So a path is a walk with no repeated vertices, and an open path starts and finishes at different vertices while a closed path finishes at the same vertex that it started at. So there's lots of terminology that we need to get our head around for this one. A circuit is a walk with no repeated edges that starts and ends at the same vertex. And then we have a cycle, which is a walk with no repeated vertices that starts and ends at the same vertex. Okay, so this is just a little bit of a summary of what those different types of so your walk, trail, path, circuit, and cycle. So are repeated edges permitted? Only on a walk. Are repeated vertices permitted? You can on a walk, a trail, and a circuit. Then we have here just a little bit our edges, so no repeat on a trail and a circuit. So open for a trail, closed for a circuit, and points repeated can be on a path and on a cycle. Okay, so moving on to the first part for this, we're looking at networks. So a network diagram shows connections or links between objects. So for example, roads joining towns or a rail network. So using this diagram, we need to answer the questions, and it says the distances shown are in kilometres. So it means these little markings on each of the edges are kilometres between the towns, so to speak. So what it says here is list the 3 paths to travel from A to C and the length of each path. So it means how can I get from point A to point C? And I need to list those. So straight away we can say, well, we can go straight from A to C. So we'd say A to C, and that would be 10 kilometres. I could go from A to B to C. So A to B to C. And I would just add up the amounts on those edges there. So I have 5 kilometres plus 3 kilometres, which would give me a total of 8 kilometres. And I could go from A to D to C. So A to D to C, which would give me 3 kilometres plus 6 kilometres with a total of 9 kilometres. Okay, so that's as simple as that question is, just saying what are the 3 paths. The next part says which part from A to C is the shortest. So if you've done this, you can then very clearly see that the shortest path is A to B to C. Okay, that is a path of 8 kilometres opposed to 9 and 10. What is the degree of each vertex? So remember, the degree means how many lines come from that vertex. So if we list all of the vertices, so we've got A, B, C, and D. So how many lines come from node or vertex A? You've got 3. How many come from B is 2, from C is 3, and from D is 2 as well. Now it says, why is this network traversable? So if we think back, remember traversable means that if you can traverse a network, it means you can visit all vertices by traveling along every edge exactly once. So if we were to draw on this, we could go, I'm traveling to each vertice exactly once, and I'm covering each of those edges, and I haven't gone over any at the, like, doubled up on any. So why is it traversable? So you can travel or move to each node or vertice exactly once by traveling along each edge exactly once. So that's why it is traversable. And the last question, which route could we travel to visit all 4 towns and drive on each road only once? So that's basically looking at where did I just draw on here to show that that network is traversable. So there could be more than one option, but I did A to B, B to C, C to A to D, D to C. So if you've got another one, that's fine, but we'd write it down: A to B, B to C, C to A to D, and D to C. So that is just being able to look at a network, being able to determine those different points and using that terminology that I went through at the beginning.